The process of bathymetry used in boats is often a time-consuming and costly process. Drone technology improvements, on the other hand, equip us with an alternative that effectively alleviates most of these issues. Team 10 is certain that we'll be able to use sonar technologies to explore the Mount Morgan Mine lake bottom. The Mount Morgan Mine is a gold mine situated in central Queensland and contains a large open-cut pit now filled with highly acidic water and is unsafe to travel on with boats. In the first part of the mission, the team will meet at the Mount Morgan Mine gate and drive to the designated ground control station. After that, the team will set up the ground control station and arrange all the necessary equipment. Once the equipment has been examined and cleared for takeoff, the survey will begin with a drone.
The water depth mapping stage will then commence after all of the essential UAV testing has been completed and the UAV has been cleared for liftoff. Due to the size of the lake and the capacity size of the UAV's battery, the UAV would require multiple battery swaps and hence multiple flights to measure the water depth of the entire lake. This is why the team has decided to divide the lake into multiple sections that the UAV would then scan before returning to the ground control station for battery swap. After returning to the ground control station for battery swap, the UAV would continue its mapping process into the next section of the lake. The UAV would fly as low as 10 meters above the water surface in each of the designated sections of the lake so that the water depth could be measured every 10 meters in a regular grid pattern using the sonar equipment. After the UAV has mapped out each of the sections of the lake, the obtained data will be used to generate water depth map for the entire lake.
The UAV that will be utilised was designed specifically for the Mount Morgan Mine mission. The UAV is an XA configuration multi-rotor quadcopter. To ensure the mission's efficiency and viability, all relevant subsystems were picked. When running at 70% throttle power, it also has a 30-minute battery life. In testing, processes that have been streamlined during the testing rounds will be used. To speed up the process and eliminate issues with the other testing criteria, these tests can be divided down into different testing phases. After all the testing has been finished and all test process paperwork has been filled out, including validation and diagnostic testing manuals, after that the UAV is ready to delivery for CASA for finalization.
There are multiple risks involved with this mission. The primary risk would be the wildlife, as due to the lake being located in a semi-remote area, it is highly likely that a number of birds could be passing by the mission area, increasing chances of an airborne collision. Weather conditions, as well as the sensor malfunction, are some of the other risks that were identified by the team. In order to minimize the probability of certain initiating incidents occurring during the mission flight, the team has created multiple barriers. A consequence versus likelihood table was also created to help the team further analyze the probability of potential damage and injuries that could occur during the mission. To conclude, the presented UV solution for lake bathroom emission has been carefully tested and risk assessed. The presented documentation is now ready to be sent to CASA examination team for final approval.